What we're about to do is basically revisiting algebra. We're going to do that by studying algebraic proofs. So let's answer the question of what is an algebraic proof. Well, an algebraic proof is a proof that is made up of your algebraic statements or reasons. And basically it's a way of organizing our reasons as we solve an algebraic equation. So an algebraic proof is solving an algebraic equation in a two-column format, justifying each step. So what I'm going to have you do is go ahead and take out your ruler, and we're going to create a two-column proof. So we'll create a line this way, and then straight down this way. And up here we'll call this our statements. And to the right we'll call this our reasons. Your reasons are going to be those properties that we just defined in the book. So let's go back to the original equation that we talked about as a class, 4 equals 3m minus 2. That is going to be our equation. 4 equals 3m minus 2. And the reason that 4 equals 3m minus 2 is because it was given to you. So we say, why does 4 equal 3m minus 2? Because it was given. Then we choose which step we want to use to solve first. Well, what we do is we are going to add 2 to both sides of our equation. And we're just going to write it like this underneath. And then we're going to rewrite 6 equals 3m because that goes to 0. And the reason that we added 2, or the property that allows us to add 2 to both sides of each equation, actually goes here. And that was the addition property. Okay. The next step is we divide 3 both sides of our equation. 6 divided by 3 is 2, and that equals 3 divided by 3, which is m. And the reason we were allowed to do that goes to the right, and that's the division property. We divided on both sides of our equation. And then finally, it is appropriate to write m equals 2 rather than 2 equals m, because we tend to write the variable first. And the property that allows us to sort of flip this is the symmetric property of equality. So this is your symmetric property. Okay, if there were any steps that you didn't quite understand in that proof, just raise your hand and let me know. And let's go ahead and try a new one together. So let's put this under the study question. How do we complete a two-column proof? And for the equation and let's use the equation 6x plus 7 equals 8x minus 5. Okay, so let's go ahead and create our two-column proof over here. Where we will put our statements here on the left-hand side and our reasons here on the right-hand side. And we want the equation 6x plus 7 equals 8x minus 5. And the reason that 6x plus 7 equals 8x minus 5 is that it was given to us. Your first reason will always be given. So the first thing I'm going to do, just because I like working from left to right, is I'm going to subtract 7 from both sides of my equation. So that gives me 6x equals 8x, and a negative 5 minus 7 is negative 12. And the reason I was allowed to do that is the subtraction property. I'm just going to put a P there. I'm going to go ahead and subtract 8x from both sides. 6x minus 8x is a negative 2x, which equals negative 12. And that, once again, was the subtraction property, and you're allowed to use the same property more than once. Then I'm going to divide by a negative 2. Divide by a negative 2. Negative 2 divided by negative 2 gives me x, which equals negative 12 divided by negative 2 is a positive, because negative over negative is a positive, 6. And the reason I was allowed to do that is the division property. And let's just say that I rewrote x equals 6 again. Well, if I rewrite the same thing again, we would call that the reflexive property. And we're not really going to do that with the algebra, but we are going to do that a lot in geometry, so I just wanted you to get used to it. Okay, let's go ahead and do another two-column proof. How do we complete a two-column proof for the equation 7x minus 3, and it's parentheses x minus 3 equals 35. So we have our statements on the left and our reasons on the right. I'm going to go ahead and get you started. 7x minus 3 equals 35 because it's given. And this property, when you have the parentheses, you have to distribute the 7 to the x and the 7 to the negative 3. 7 times a negative 3 is a negative 21, which equals 35. And what allowed us to do that is the distributive property. Okay, from this step, I'd like for you to pause the video and finish this last proof on your own, and then you'll begin your practice, and that will end the video.